Long time no see, everybody. Thank you for joining me. I'm really looking forward to this panel, which we kind of had to put together last minute because we were originally going to talk about future of launch in general and the more like, oh, what is it like being a launch startup in this day and age, especially with people like Peter saying like, oh, we're going to become fully integrated and eat all the launch companies. But you guys are doing something really unprecedented, really, and interesting, and I'd really like to hear more about this. It's hard enough getting to space in the first place, but you want to bring things back in one piece, ideally, and on target, especially. So maybe we could start by explaining exactly what you are attempting to do in this matter of down mass or orbital return, orbital delivery. Justin, why don't you?
Yeah, absolutely. Well, yeah, thank you guys for having me. Justin Paschetti, co-founder and CEO of Inversion Space. We're building autonomous reentry vehicles that are designed to store cargo in space, think like an orbital warehouse, and then deliver that cargo anywhere on Earth in under an hour and land with 15-foot landing accuracy. When you start to do this, you start to introduce the ability to touch any place on the globe very quickly. This is the same level of transportation technology iteration that happened 100 years ago with the airplane, where before the airplane, it took weeks to get from one side of the globe to the other. Right now, it only takes about a day. And our goal is to make it so it only takes about an hour. And by having access to the whole globe, you actually can generate a lot of value for customers. And so we're building that kind of reentry portion of that gets us from space down and land directly on the ground.
Gotcha. And Kelly, you're doing up and down.
Yes, and I think Peter was right. You need to look at full vertical integration. You have to look at differentiation as well. And so when we think of launch, we think full reusability, not just the first stage, but the second stage as well. And when you incorporate the second stage into full reusability, that allows you to bring things down as well. So as we're sending things up routinely, and we're thinking daily, reusing that hardware, we can also bring things down with that second stage. And so that is a market that, while I do believe is untapped right now, I think it's going to be huge. And I think as we grow and as we offer those rides back, we'll see in-space manufacturing, we'll see other types of things coming down, and that need will only increase.
What I love about this panel is that just like a couple of years ago, this whole business would have seemed to me basically completely insane. I'd be like, what, you can't build a business? Like, it can be done, obviously, you can bring stuff back from space, but building a business around it is a wild idea. But now, like when I was reading about these companies over the last year or two, I was like, it actually seems really practical in a way, like practical in a crazy way. But when did you both clock that this was actually this was the way forward and not, the usual terrestrial or usual high-cost delivery methods?
Yeah, well, so I think we want to start off by looking at what is space useful for in general, right? What is this platform of space adding value to? And right now, there are kind of two main markets in space. There is internet from space or communications, and there is like imaging or just like Earth observation. What do those two things take advantage of? They take advantage of space's ability to cover the whole globe with very little infrastructure, right? Starlink can now serve every country without having to run fiber all around the globe. And so if space's value is the coverage of the world and the then distribution of whether it's information, we asked ourselves, okay, what if that was used for cargo instead? And that was kind of where that clear understanding of, oh, there is a third use case for space, which is distributing cargo all over. My co-founder and I came up with the idea for Inversion late one night back in 2020 when there were a bunch of wildfires in Los Angeles. And we were like, well, what if you could drop water from space and put out the wildfire, right? Now, obviously, like that's like maybe not the best use case.
Maybe later.
But the concept of responsive, immediate access to whatever part of the globe you want, just as right now you have responsive, immediate access to take a picture of whatever part of the globe you want. That was where we saw this, and over the last 3 or 4 years, there's been a huge growth in especially the government's interest in being able to move quickly to remote areas.
Gotcha. Well, let me just say that, like, you say, oh, we had this idea, but of course, Robert Heinlein had the idea in Starship Troopers and a bunch of other, in sci-fi and stuff. Everybody has thought of this for, a century and longer, saying like, oh, what if we could, go up to space and then go back down to Earth? And we got, hell pods and other, ways of thinking about it. But it sounds like the moment when you thought this was actually realistic is when the government, basically, when there was a customer, someone said. So you started thinking, somebody might actually pay for this to be done.
Yep.
Is that about right?
Yeah, so this is not a technology problem. This tech has been around for 60 years. The concept has been around for longer than that. In 2006, DARPA studied the concept of delivering cargo anywhere on Earth very quickly with rockets. And they came to the conclusion, hey, this is not a technology problem, it's a cost problem. Right? Cost is the key thing. I think we could all agree that access to the whole globe is really valuable. Right? If you can do that in an hour, it's super valuable. The question then becomes, to what Peter was saying, how does the value of that compare to the value of the cargo, right? Or the cost of that compared to the value of the cargo. And as launch costs have come down, especially with what Stoke is doing with reusable rockets, that has made it where now you can start to really have these kind of high value assets, especially strategic assets. Because the key thing for inversion is that our value is not actually the cost and speed of delivery, it's the ability to go and deliver cargo anywhere on Earth in an hour, right? You have, let's say, medical supplies stationed in orbit, right? Where do you need them? You don't know. But the comparable cost to have that on the ground is actually now higher than if you had it in space, right? We've actually flipped that cost curve, where it's cheaper to put things in space to have global access than it is to have all of those pieces of cargo with all the airplanes, with all the people, with all of the facilities on the ground around the globe.
Well, I think we could come back to this the cost piece, because I'm personally not convinced that this is actually the case, but it may be soon. Kelly, you have a whole other layer on this, which is the reusability and the full launch stack. So when did you decide? When was it clear to you and Stoke that this was the future? It wasn't expendables. It wasn't wasn't taking a ride on somebody else's thing to do down mass. Was a full reusability stack.
So when you think about costs and you think about launch costs, and you compare it to, say, aircraft, you think, I'm not throwing away my aircraft every time I use it, right? Mm-hmm. You use them over and over again and use them quickly. There's very minimum refurbishment between those times. And as a matter of fact, when a plane arrives, they clean it, you immediately take it off again. And so that's where we see the future of launch. That's where we see the entire industry going. And that's where we see really true, very low launch costs coming from, is the ability to reuse it, but also do it very, very quickly, and get that into a day or so. And then I would say we didn't naturally think about down mass. It kind of came out of the fact that we were developing this fully reusable second stage that then would just come down, land in any kind of environment. It could be very austere, it could be on a pad, or it could be in the desert somewhere, or even on the moon. The protection that base heat shield provides is incredible. So it's not like the fragile ceramic tiles where you kick up the dirt and they crack, you have to inspect them. It's incredibly robust. And so once you actually have that second stage in orbit, you can think about all the different opportunities and things that then you can bring down. So then you're actually utilizing the ride up, and you're reducing those costs from usability, and then you're also able to open up the market to bring things down on that same ride. So that will further reduce the cost for launch and reduce the cost for down mass. And then when you think about what the government will need and the point-to-point delivery, we can go up and then immediately come right back down and land anywhere. Or you can have them, like Inversion does, waiting, ready at a moment's notice to bring down.
So how do you, with the sort of, obviously this still needs a lot more development, both for the down mass stuff especially. How do you build a business around something that doesn't exist yet? How can you stay alive and develop and say, oh yeah, in a few years we'll have this capability, but right now you need to run a business, you need to hire, obviously you take investment and stuff like that, but how do you keep how do you not go out of business before you actually have the capability that you'll make revenue with.
Yeah. I mean, well, this is a challenge for all hard tech companies, right? Where you have long development timelines, and how do you go from an idea to a revenue-generating business that needs tens to potentially hundreds of millions of dollars to get to that place? I think there's two key ways. One, obviously, venture capital, right? That helps bridge that gap. But the other is, if you are, especially with the military, right? The military is used to paying for the capabilities they want before the capabilities exist, right? They give Lockheed Martin a contract 10 years before any airplane's ever produced. So while that's not normal in the commercial market, the military is very used to doing that. So we're able to leverage that where they want this capability. They're willing to pay early to help us develop it, to make sure that we are meeting the requirements that they have, and to kind of give that clear pathway to production contracts, right? Where, hey, we want this, here's some money, go build it and demonstrate it and get into production. The other key thing is you need a beachhead market, right? We're not going to go and the first day deploy 1,000 of our vehicles or 10,000 of our vehicles.
Some startups think they are.
Yeah, I mean, you should. I think manufacturing capacity is the hardest place, right? And scale up a production is really difficult. So where are the opportunities to use the same capability, the same technology that you're building, but for maybe a slightly different market that you can fly 1 or 2 off missions? And so for Inversion, right, that is being a reusable in-space platform, right? Testing things in space and bringing them back so that people can analyze them. Now, that's a few off missions a year, right? That's not going to transform the world, but that gives you this kind of bridge to this larger delivery from space market. And that's the kind of key way that you bridge that gap.
Gotcha. And Kelly, I think we were talking about this a little before. I was under the impression that designing a reusable rocket would be a much more costly and time-consuming process than, say, starting with a expendable version and then gradually moving to reusability, like what they're doing with Rocket Lab and what they did with Falcon 9. Things like it's like there's an established path here where you say, oh, we start expendable, then we go reusable. But you are going straight to reusable. Is that actually what is the benefit of this? I would have said this is why I don't run a rocket company.
I would say it's incredibly difficult to use an expendable architecture and then move it towards reusability. We feel that you need to think about reusability from the very, very beginning, which is why we started with the second stage. We demonstrated that, and now we're moving on to the first stage. And so I would say it's, with that in mind, building a reusable architecture is no different than building an expendable. And to your point about staying alive, execute. You have to execute. You have to continue to do what you said you were going to do on the timelines as you said. Stoke is incredibly lean. We hire the best in the business, and we move incredibly fast. And so even if you look at reusability, from seed to our second stage test, we're the fastest rocket company in history to do that. And then for our first stage as well, I think it was 17 months from clean sheet design to engine hot fire. So we are, and that's not even starting with, say, a previous rocket and just building on that. This is a brand new company that we're doing that with. And so I would say, the investors see that, they see how well you're executing, and that's what they look for, is that continued execution. But I would agree, dual-use technologies are huge. It's what the government is looking for right now, especially in launch vehicles. They want to see a commercial and robust plan, and they want to see their capabilities kind of augmented by the commercial market. And so I agree, going towards the government and looking for them to kind of help in some of the development costs. We recently received the DIU contract for things very similar to this. And so looking for that to kind of augment the investor money and then moving towards that commercial market and then pulling in for the government missions as well.
Let me ask this, Justin. You're mainly doing the down mass. Kelly, you're doing up. You're doing launch and down mass. Yes. Can you guys fight about which is better?
Would you like to go first?
You want us to fight?
Well, there's obviously there's advantages and disadvantages to both approaches. Would you want to obviously you did not choose to develop an entire launch platform for a good reason. But you've decided to do that. These are two hugely different sort of business proposals. But in the end, you both are maybe providing a competing service when you look at when you may be competing for the same contracts and things like that. Do you think that one of your approaches has advantages over the other in a purely non-conflicting way?
I don't think we're competing. I would say we tend to look at the newer space companies, whether it be us and SpaceX or some of the other rocket companies, as there being a limit. However, I think right now we're in the very, very beginning points of this industry, and I only see it expanding. And so I absolutely believe that there'll be good, applications for both of us to exist. And I don't necessarily believe that one, beats the other. I think that there's times when it makes sense to use their method, and times when it makes sense to use ours. And I think the market supports both.
Yeah, I'll just talk about kind of from Inversion's perspective why we're going down this path, right?
Now is when you strike.
Right.
With the big argument. Yeah.
So
wait, he's not supposed to strike.
Perfect time.
So from Inversion's perspective and just why we're doing what we're doing, I like to relate it back to the internet, right? You need the infrastructure for personal computers and just general information distribution in the internet to build any sort of business on top of it. Amazon didn't go and build a PC, right, or an operating system. They leveraged the existing infrastructure that is available. And when we were starting the company and coming into the market, we took the approach that, hey, the infrastructure is being laid by others, right? Whether that be Stoke, Rocket Lab, SpaceX, what have you. We don't need to bite off that, right? What do our customers care about? Our customers care about getting their cargo somewhere on Earth very quickly, right? And if I can eliminate a large technical component of that by flying on another rocket, that makes my business able to move faster. At least that's kind of our view. With that said, though, we are now reliant, right, on a robust commercial marketplace of launch. And if you look at it today, there is not that. There is SpaceX, and that is basically the only option if you want to do a very low-cost launch. And then your next step up is a Rocket Lab Electron. And so from Inversion's perspective, we love that there are a lot of players coming into the launch game, right? We want fully reusable rockets to exist because that just makes our main constituent cost reduced.
And I would say there is a subtle, I would say, difference. With our second stage, we envision a time frame when we are capturing things, when we're moving around, capturing things using robotic arms to pull them in and bring them down. And so there's that scenario as well, which is not necessarily I'm going up with the payload I anticipate I'm bringing back down. I'm going up with a completely different customer and different payload. Right, and so there's that type of scenario that kind of separately exists than the idea that I'm going up with a payload and then bringing that same payload down.
So can we talk about some actual? By the way, I love that there really is this proliferation of business opportunities here. When you look at this capability, it starts multiplying in your brain. You're like, oh wait, we could do this. Wait, we could do this. We could do this. But as it stands, the costs are still going to be very high. Can you project at all the actual costs per kilogram, for instance, to bring down? If I was going to bring down a kilogram of water, whatever it is, for your service, do you have any kind of actual projection of the costs involved and how that will change over time? And then for your part, that's sort of the same thing, but if you're going to be operating, giving other options, how do you price that?
Yeah, absolutely. So we actually don't look at it at a $1 per kilogram basis because
I do.
But our customers don't is the key thing,
no.
Right? Our customers look at it at how expensive is it going to be for me to have full global access to the whole globe per year, right? Because that's what they pay right now. How expensive is it to have these kind of materials distributed around the globe? Right, and for context, that is like billions and billions of dollars.
And this is,
today.
to be clear, we're talking about like a depot in, wherever we have a base, which is practically everywhere.
Correct.
And you keep your water and ammo and gas and what have you.
Exactly. Yeah, one of the key functions of the military is to be expeditionary, right, and be able to access and be anywhere on the globe when and where they need it with cargo. And so, from our side, we are looking at in low tens of millions per year to cover the entire globe with cargo, right? And for context, like maintaining a single airstrip for an airplane is like $30 million a year just to maintain it, right, and have the people and infrastructure around it. So it is when you look at it at a per year to have access to the whole globe, it really starts to make sense.
And what you're actually saying is that, let's say I'm the Air Force or whatever, and I am buying access to the globe, but practically speaking, am I buying one delivery of 1 kilogram per year at this? What is the actual product in terms? Like, give me some kilograms here.
Yeah, well, so our next gen vehicle will be close to a ton of cargo. One way I'll put this is an F-22 has never seen battle, right? We've never used an F-22 in battle. And so how often is an F-22 amortized per mission? It's like the entire price of the program. So the customers just don't think in this like dollar per delivery perspective. They don't think about it in the dollar per number of times an aircraft carrier has had to engage a target, right? They think about it in force projection. They think about it in what happens if I do need this. Yeah.
So I'll add numbers.
There we go. Now we're talking.
They have their numbers published.
You're on notice. The numbers are coming.
Well, simply because if you think about the idea that we're looking to reduce launch costs by about 20x, using the fully reusable vehicle, flying daily, and so we're looking at hundreds of dollars per kilogram, right, as opposed to what you're seeing now, and that's not including down mass, right? So if you're just considering that is the cost to send up and then bring just the hardware, the rocket down, you can then add on the, essentially the customers and pull things down as you're making your return trip. And so that would be even less. And that would further reduce the overall launch costs. So you would see things in down mass land that are even lower than that.
So tell me about on your side, the scaling up of things. I had asked Peter the same thing with Neutron, but if you today demonstrated your core product and you have your orbital launch, we're good, and you have your first down mass, everything goes nominally. What does scaling up look like, and what kind of timelines are we talking about here to get from the one demo to 1000x and the kind of cadences you're looking to do? Obviously forever, but what is realistic? What does that scale up look like?
We are definitely starting with expendable, and so our rocket is architected to be reusable. But as SpaceX kind of demonstrated, you send it to orbit, make sure you can get to orbit, and then you slowly kind of do different demonstrations to make sure that you can get down and pull the hardware down, return to launch site, and so you're just creating that overall very routine, boring operation. And so that we'll kind of slowly build that out until we can refurbish it and replenish it on the order of days. So we're not looking at something happening, in the same year of launch and then that full reusability with 24-hour turnaround. It's on the order of a couple of years. But that scale out will naturally happen as we continually demonstrate our technical milestones.
I love the idea of a time to boring, where there's a Falcon 9 goes up now, and you're like,
yes,
it's it's noise pollution if you live in the area.
Yeah.
But because it's boring, it's very exciting. Obviously, it's fabulous. We're all here because we love space, but it's it has become ordinary, and that's such a huge, that's such a great thing to accomplish as a society, that we can send up rockets that are, and it's ordinary. And once you accomplish that, you're like, it's ordinary. It's just an everyday thing. And
I tried going with the tagline, "We make launch boring," but that got nixed.
The board didn't like that. No. The investors. So how about you? Once you drop, you do your test download, and then what do you have to do to get to the kind of scale where you really can cover do a global coverage thing.
Yeah, absolutely. So when you look at an aerospace vehicle or just any type of like large product, the rate at which you can scale up is almost intrinsically linked to how you design that vehicle. Your ramp rate and your cost curve that you actually come down is almost entirely locked in to the product by the preliminary design review of that product. And so if you're choosing very exotic materials, very exotic manufacturing methods, it's going to be a pain to produce a lot of them and to produce them inexpensively. I'll always gas up Rocket Lab, but one of the coolest things for them is that Electron is ramping faster than Falcon 9 did, right? Like that's crazy, right? Just conceptually.
Yeah.
And so one of the things that we focus a lot on is like, yes, you need to be able to make one, but how do you make 100? And so for inversion, we're somewhere between the production capacity of like a large constellation like Starlink and rockets, right? I joke that we are a very similar manufacturing company to like hypercar manufacturers, like Bugatti or Koenigsegg, because they're doing like 100 a year or so, and they're very expensive. They're roughly the same size as our vehicles, that kind of thing. And so if you don't design in the ability to ramp your production rate, you'll just never be able to do so. And so that's one of the biggest things that we're focused on, is not actually the technology to make delivery from space work. Like that's been done since the 60s. The thing that hasn't been done is making it at an affordable price and making a lot of them.
And I would caveat that with if you are expending. If you're expending, and a lot of newcomers to new space expending their second stage, and when you're expending your second stage, you definitely have to think about production. And you run into production limitations. How often can I fly is going to be limited by how often can I actually produce a brand new second stage. And so if you are fully reusing, you create a fleet. Right? And so you're going to have some sort of production limitations there. But I would argue that that's not going to be the limitation for how often you can launch. If you're truly reusing as over and over again as we plan to, and you're doing it daily, it becomes far less of a discussion around the production and much more of the reusability argument.
So we only have a couple minutes left. I want to talk about, I think that's something that everybody thinks of when they hear about this sort of like this down mass thing of like, hey, dropping something from space. I can't be the only one that thinks like, yeah, that's going to be used for bombs. Yeah, that's going to be used for military purposes that are not going to be disclosed. Like, nobody's going to drop, like, I mean, sure, there's some medical supplies, but, it's in vacuum, it's up there. Like, what is valuable enough to drop? Except, like offensive capability in some cases. Like I can picture dropping a drone into the middle of nowhere where past the anti-drone defenses, that kind of thing. Like my mind immediately goes here. Well, yeah, and also I play video games. So that's the obvious like thing. You'd be like, oh, call in the drone. But it does seem like the kind of thing that the generals and admirals get these stars in their eyes. They're like, oh my God, we're finally achieving this like crazy sci-fi warfare that it can be used defensively and for to save lives. But what are the actual payloads we're talking about here that are actually valuable enough to keep in orbit and be ready to drop on short notice? Or in your case, I'm picturing scooping up enemy satellites and bringing them back down. It seems crazy, but then like a couple years it's going to happen, right?
You're asking me if we're going to scoop up enemy satellites and bring it down.
Yes.
I would assure you that if I knew the answer to that, I probably wouldn't be able to answer that here.
Unfortunately, yes.
So, but I don't know the answer to that. I would say think about it as debris removal, space junk. Those are good things. Even if you're thinking about, say, lunar samples or bringing things back from in-space manufacturing. So you have a space station and it's operating, and they need to send whatever they're doing down. So think of it in terms of that. It's not necessarily purely payloads in the military sense. There is a huge amount of commercial applications that could benefit from this.
Right. There is value outside of my crazy, cynical ideas, but
video game.
I have to ask about them. Yeah, I mean, it's going to happen for sure.
So one thing I would say is that we already have ability to deliver munitions anywhere on Earth in under an hour.
Sure.
Like, we can do that, right? Like, the United States can do that. any sort of reentry vehicle in the commercial space that you're like would be hearing about is like literally designed to slow down. Like the whole purpose of the vehicle's design is to slow you down so you can touch down softly. And one of the most valuable per kilogram things is information. Right? It weighs literally nothing. And so when you think about like, what do I need somewhere very quickly? Well, a lot of it is situational awareness, right? Being able to understand what is happening in a specific area to inform other activities, right? So when do you want to go and deploy these systems? Gathering information, having communications nodes, those types of things outside of this kind of offensive capability really expands the aperture for what people will use this for.
So I really should spend more time just talking to people about these very interesting applications that I immediately went to, capturing enemy satellites. But we'll get there. But we are out of time for today. We'll talk about capturing satellites next time. Thank you so much for joining us, and thank you for joining us.
Thank you.
Thank you.